exactly the same speed. Sometimes they speed up or slow down. When objects change their speed, they change their velocity. We like to call that acceleration. Now, there's two ways to talk about it. Positive acceleration means speeding up. If a car was traveling at a constant velocity and then started to increase the speed that it was traveling, we would call that positive acceleration. We can also talk about negative acceleration, or slowing down. If this car again was traveling at a constant velocity and then slowed right down, we would say that it was decelerating or had negative acceleration. When we talk about acceleration, we have to talk about how much the velocity has changed per unit time. There's an error in your notes that talks about units for acceleration of meters per second or kilometers per hour. These are units of velocity, so we're going to need to fix that in our notes. Cross out the word acceleration and change that to velocity. We talk about how fast we're going in meters per second or kilometers per hour. Acceleration is going to tell us how that velocity changes each second or each hour. Acceleration units are often meters per second or kilometers per hour per hour. We can also write this as meters per second squared or kilometers per hour squared. Either way, there's going to be 2 units of time for an acceleration type problem. Now, acceleration and deceleration imply that a force is being applied on the object. If I'm applying the force in the same direction I'm traveling, then it causes the object to speed up. For example, if I'm at the mall pushing my shopping cart and I want it to move faster, I'm going to push harder in the same direction that I'm moving. My acceleration force is in the same direction as my velocity. When I'm decelerating, the force has to be applied in the opposite direction. If my shopping cart is moving too quickly, I'm going to pull back on the handle. My acceleration force will be negative or backwards of my direction of motion, and that will slow me down. But in both cases, I'm applying a force to the object in the same direction to speed it up and in the opposite direction to slow it down. Now, when an object speeds up or slows down at a constant rate, we call that constant acceleration. So imagine that you're beginning at a full stop. Your speed is 0 meters per second, and you start traveling to the right. And after 1 second, your speed is now 1 meter per second. After 2 seconds, you're at 2 meters per second. Each second, I've increased by 1 more meter a second. My speed's increasing at the same rate. This would be constant acceleration. I could also slow down at the same rate and have constant deceleration or constant negative acceleration. But as long as each unit of time, the amount that I speed up or slow down is the same, then I could say my acceleration or my deceleration was constant. Usually, however, we talk about acceleration and deceleration in terms of averages. I know that if I'm driving my car and speeding up from a stop sign, I might not have exactly even pressure on my gas pedal, and my acceleration might change a little bit until I get up to the legal speed. So typically we'll look at the average acceleration. So suppose I start at 10 meters a second. I'm driving along at 10 meters a second, and then after 10 seconds I've sped up to the point of being 120 meters per second. How much have I accelerated? Well, I need to know the difference in my velocities. I need to find the change in my velocity over a period of time. I know my starting velocity then is 10 meters a second, and my final velocity is 120. If I take my final velocity, my v2, and subtract from it my starting velocity, my v1, I have a difference of 110 meters per second. 110 meters per second is my change in velocity. It's how much that my velocity has changed by. If this change in velocity happened in a total of 10 seconds, my change in time being 10 seconds, then 110 meters per second divided by 10 seconds, my change in velocity over my change in time, works out to be 11 meters per second, or 11 meters per second squared. My object accelerated at a rate of 11 meters per second faster each second than it had the second before. It's kind of strange sounding, but basically we're talking about the rate that our velocity is changing at. Acceleration then has to be a vector quantity. Direction is a key component. Positive acceleration means I'm speeding up, so the force is in the same direction. My acceleration vector would point the same way as my velocity vector. Negative acceleration or deceleration then is slowing down. So I'm applying my force in the opposite direction. So in the case of slowing down, my acceleration vector is actually pointing the opposite way of my velocity vector. Let's do a bit of an example. Suppose I've got a vehicle on my highway and it's traveling west. The direction of travel then is to the west, and my velocity then would be west. If the car begins to speed up, that means that the acceleration is in the same way as the direction of travel. My acceleration would also be to the west. If a few minutes later the driver takes his foot off the gas and starts to slow down, his direction of travel is still to the west. But if he's slowing down, then a force is causing him to not move forward as fast as he was, then my acceleration vector would be in the opposite direction, to the east. Something was opposing his direction of travel. We can calculate an example of acceleration with you. Suppose we have a person called Ima Speedin. And Ima Speedin puts the pedal to the metal and increases her speed as follows. They're going to start at 1 mile per hour at 0 seconds, 10 miles per hour at 1 second, 20 miles per hour at 2, 30 miles per hour at 3, and 40 miles per hour at 4 seconds. We can see that each second as it passes, Ima's car is going faster than it was the second before. It started at 0, a second later we're at 10 miles an hour, and after another second, 2 seconds have passed, we're at 20. After 3 seconds have passed at 30, after 4 seconds have passed at 40. How do we figure out the acceleration of our car? I know that my acceleration will talk about my change in velocity over my change in time. How much has my velocity changed by? Well, we started at 0 and we accelerated until we got to 40. My V1, my starting velocity was 0, and my V2, my end velocity, was 40. My change in velocity then will be V2 minus V1, or 40 miles an hour. I have to divide this by the change in time. How much time has elapsed? Well, we started at time 0 and we increased for 4 seconds. So my time has changed 4 seconds from 0 seconds. 4 minus 0 is a total of 4 seconds. So now we have 40 miles an hour over a change in time of 4 seconds. We have 2 different kind of time units, but for grade 10 that's going to be okay. I'm not going to have you go and change your hours into seconds and change this into a value of miles per second. Let's just keep it simple. 40 divided by 4 is 10. My acceleration then will be 10 miles per hour per second. That means that each second I'm going 10 miles an hour faster than I was the second before. You guys can practice calculating acceleration and deceleration in task 4 in your work booklet, and we can work on questions 1 through 9. As always, please feel free to message me if you've got any questions about this task at all.